Thanks for coming. Welcome. I started kind of updating the slide last 2 days ago, and have a funny feeling because I'm talking about Netflix while working at Lincoln. But anyway, here we go. So whenever I say the word "we," it means Netflix, not Lincoln. Okay. Otherwise, I have to keep repeating Netflix, Netflix. So this talk is basically a combination of the talk I gave at Silicon Valley CodeCamp and Netflix architect Adrian's talk at the Cloud Meetup about a month or two ago, as well as at QConf, as well as my co-worker at Netflix. He also gave another talk about cloud at QConf in recent months. So I kind of merged all these three together. And I do have some Christmas presents for some of you. I do have some books. Unfortunately, I don't have as many books as many attendees out there. So I'm going to be asking some questions, some trivial questions about Netflix. And some of you, if anyone can answer the question, you get a book. Huh? Netflix ads? I don't know. But these books from is host a website in the cloud. It's about Amazon Web Services. It's really relevant for this talk. And thanks to Van, I don't know how many of you know Van. He is the chair for the Google Silicon Valley Technology Users Group. He's very active in the developer communities and stuff like that. So when he saw the email that went out about this talk, and then he sent me an email and said, "Hey, I have 30 books about Amazon Web Services. Do you want it?" I said, "Absolutely. I'm sure some of you will be interested in this." Okay? All right, so feel free to just interrupt me and ask questions anytime along the way. Okay, let's get that out of the way. So the agenda for tonight is why Amazon Cloud, why Netflix is moving to the cloud, as well as why we pick Amazon. We're going to take a tour of the major Amazon Web Services. That might go quickly or slowly, depend on the level of interest out there on this topic. If enough people have working experience with these services, then I'm just going to go through very, very quickly. And we'll talk about how Netflix used some of those services in the architecture stuff and how things work. And then we'll share with you some best practices from the perspective that we learned over the last year and a half working with the cloud. Okay? So to start with, first question of the day. Who knows currently how many subscribers does Netflix have?
18 million.
Close. Very close. 1 million? 17. There you go. So we currently have about 17 million paid subscriber, right? So these are paid subscribers that are willing to pay $8-10 a month. One more question before we proceed. Currently, how many countries that Netflix can provide a subscription service to? 2. They are US and Canada. So Netflix just expanded to Canada recently, roughly about a couple months ago, just for streaming only. Cool, so there'll be more questions coming up. All right, so why Amazon Cloud? Well, the bigger question probably is why cloud in the first place? Netflix has 2 data centers. They built one this year, the beginning of this year. So why did we decide to go to cloud in the first place? So I think the main thing one of the main reasons is Netflix does not want to be in the business of building data center and managing data center. they don't view that as a competitive advantage over competitors. They really want to focus on the core competence of what Netflix does really its best at, right? Which is connecting people to the movie that they love. That's what Netflix is all about. They don't want to be hiring a lot of engineers and sysadmins and managing the data center and stuff like that. So I think that's one of the main reasons. But the other main reason, the other also good question, reasons are because Netflix has been growing pretty rapidly. The subscribers have been increasing steadily. And with that comes a lot of requests for capacities, powers, and the company wants to achieve really good scalability and availability because it's a pay subscribers, right? You want to watch a movie whenever you want to watch it, and we want to able to provide that service to you, to subscribers. The other important point is the cloud gives this to whoever wants to use the cloud, is the elasticity. Because of the high growth, we're able to move faster with the cloud than without a cloud. Because of this. Whoop, wrong button. Because of elasticity. Right? I'm sure some of you know what that means, but we'll talk a lot more in that in seconds. One of the examples is every year there's an Oscar, as you know. And every year around the Oscar night, after the Oscar, people would go to Netflix and look for the movies that they see. That's when we get a lot of traffic. So the week before Oscar, we all scramble to add hardware, right? So with the cloud, with elasticity property that it provides, we are not as stressed as before because we can leverage that. And once the Oscars are over, we shut down those machines. Okay? And constantly we're adding new devices to support new devices, new TVs, new DVD players, and stuff like that. And that put a great demand on the capacity in our data center and stuff like that. So a combination of all this stuff, I think that's really the reason why they decided to go to the cloud. Okay? So now, data side. Obviously, we all know that Netflix chose Amazon. And among the reasons are because Amazon is one of the most mature cloud providers. They have a set of really highly scalable and reliable infrastructure pieces, naming EC2, SimpleDB, SQS, S3, and all these services. Yeah. No. It's a very good question. When we were working on the cloud, the main focus to get the move to the cloud as fast as possible. Cost is secondary. We were making money. So, good question. I forgot to do a survey at the beginning of this talk. Is how many people are familiar or have worked with Amazon cloud services like these guys? So about more than half of you. Okay, cool. So so most of you are familiar with these acronyms, I would gather, right? So what that means is for the next part of the talk, I'm going to go really quickly. Okay. So continue with that. So if you kind of categorize all these services that Amazon provides, they can kind of fall into these groups, right? For compute would be the EC2, the EMR, that's for doing map redos. For database would be the RDS for doing MySQL, running MySQL over there. For messaging, there'll be SQS and SNS. For storage will be SimpleDB, S3, and EBS. So the next part of the talk is basically kind of give a quick overview of this. Since most of you are familiar with this, I'm going to go fairly quickly. But For some of you that haven't have a chance to work with these, feel free to stop me or slow me down. Okay? So can someone explain what an EC2 instance is?
It's a server in Amazon data center. You can rent for compute unit, so you don't even have to run the machine.
Right. So the one thing to add to that is a virtual computer. It's not a hardware computer that you have on your desk, right? So they take a hardware box and they use Zen virtualization platform or technology to create multiple virtual computers running at the same hardware box. Okay, so it's a multi-tenant hardware box that's hosting multiple virtual EC2 instances. Okay. I'll give a story later about this multi-tenant issues. So what you get is the elasticity because they can create a bunch of these EC2 instances on the big box. Right? They got a big box that create maybe 4 of these guys running on that same hardware box. And as a user, you have total control of this. Treat it as your own computer. As you have root access, you can do anything you want. You can pick the kind of operating system that you want on it. Windows, no Mac though, just Windows and Linux. And it's fairly secure because they provide that inside the Zen virtualization layer for a bunch of securities. So with an EC2 instance, you have an AMI, which is Amazon Machine Image, which contains an operating system. And then you're going to install your application, Tomcat, your Spring Power application, whatever that is. Each EC2 instance comes with a certain amount of memory, depends on the size that you pick, and it's a storage, but it's non-persistent, meaning that if that EC2 instance goes away, whatever's on that disk is gone. Okay? How do you get to that EC2 instance? It has a pair of private and public DNS or IP address, as you will. The private one is usually used inside the Amazon data center. The public one is what you can hand out to somebody at work or your customer. Typically, you don't do that. But basically, you can access that EC2 instance from anywhere in the world. So for a customer-facing application, you don't want to do this because when that EC2 instance goes away, that public IP is going to disappear and go back into the pool, right? So it's kind of a transient public IP. So that's why they have this thing called elastic IP, which is, think of it as a static IP. So you can take that static IP and map that to an EC2 instance. And then you can use DNS name, whatever, and then somebody can access that EC2 instance through that DNS name. Okay. Because elastic IP is a scarce resource, there's a limited of these that you can request. And this is one of the services that you get charged when you don't use it. They give it to you, you have to use it. If you don't use it, you get charged. It's the opposite of among the other services. So this is kind of a table that describes different types of EC2 instance that you can pick. Depends on the memory and the storage that you need. Most of the time, people go by this name, M1 small, M2 small, C1 medium, whatever. The cost ranges from 8.5 cents per hour to $2.40 an hour. The most expensive one is the one that runs Windows, the Windows OS. For all serious applications, you definitely avoid these guys. Most of the Netflix stuff running on the C1 or the M2. Because of multi-tenant issues, these guys, your application running on there, remember like they can have like 2 EC2 instances running on the same box? And if another application running on the other EC2 instance that's sucking all the bandwidth or CPU out of that box, guess what? Your application is going to be starved. CPU is being stolen from you, basically. So that's kind of the things you have to monitor. to see how much is CPU being stolen from you.
Any assured performance that you can expect from any of these virtualized servers?
Yeah, depends on the instance. Certain instance, you pretty much get the dedicated box as well. So that way you can kind of have pretty high confidence that you get certain amount of performance. But you certainly want to do benchmark and performance testing.
My question is, on the small instances, are there any guaranteed minimum performance levels?
Oh, okay. For the small ones, they what they say is for a one computing unit equivalent to some 1 point some megahertz Opteron CPU. But if your application is not busy, then they have the right to steal the CPU and give it to the other one. Yeah.
Are they guaranteeing some number of cores for each instance?
Well, they go by the computing unit, not core, right? Because let's say they have a box of 4 cores, and they're going to split that up. So the currency they deal with at the computing unit that matches certain Opteron 1.2 gigahertz capacity, or the basically how fast it's equivalent to. That's all the.
I'm sorry, I do want to make sure thing clear. Is it the case that if I'm paying for a given computing unit, like 4 of them, I don't always get that? It might be a function of what's happening in my physical box at the same time.
You will get that if your application is busy.
If it's not busy, I don't care.
Yeah. Okay. But that's one of the things you have to kind of deal with, monitoring the CPU, how much is being stolen from your EC2 instance. All right, so in terms of launching those, they provide scripts, and you can go through the consoles, and you can use third-party write scales and stuff like that. Typically, AMI are stored in S3 or EBS. We'll talk about those. And they have a set of existing AMI that for anyone just to play with, just use that particular AMI and launch a new EC2 instance. They have out-of-the-box EC2, Linux, various versions of Linux, and stuff like that. So that's basically what EC2 instance is. And the other topic is to achieve high availability, they have a concept of a region, right? A region represent like a US East Coast, US West Coast. It's a region. Within a region, they have multiple availability zones. Each one of those represent a data center, right? So a region can have like 3 zones. So typically develop applications are deployed into a particular region, but multiple zones. So that way you can achieve high availabilities if one of the zone goes down and things like that. Okay. And depends on where your customers are. You might want to deploy your application close to your customers. You can pick multiple regions. In terms of securities, there's a concept of security group. Basically, you have an application, you deploy into maybe 20 EC2 instances, and you give that a name, right? And then you assign some access rules, basically, meaning that only certain other security group can access to that all the instances in that security group. So it's also another way to avoid unintended access. For example, if you have different services within, let's say Netflix, we have different services, and only certain allow other applications can access a certain application. That way, we can detect unintended access, as well as other customers' application, because all this stuff's running inside Amazon data center, right? So you want to protect yourself as much as possible. And this is one of the ways. So it's fairly easy to do that. So for any customer-facing application, you definitely need to use the load balancer or ELB, Elastic Load Balancer. So that way you can achieve high scalability as well as availability. And this guy is pretty cool. It can distribute the incoming requests. Wrong one. I keep clicking the wrong button. Incoming requests to different EC2 instances in the same region, but it can be in different availability zone, right? So that means if you deploy your application across basically data centers, if one goes down, your application is still accessible because of this guy can handle that. And this can terminate the income requests, terminate the HTTPS as well for you. Okay. And it has a certain amount of health check that you can configure and the interval and stuff like that. So it can detect when your instance goes down and would not route traffic to that particular instance. For example, like that. So it's a very useful piece of infrastructure service. Auto scaling is another nice, very nice feature. If your application has that kind of demand curve, you can like automatically launch more EC2 instances based on the need. And as the traffic dies down, you can terminate some of those instances. So elasticity plays a big role in this in terms of saving. Yeah. Yeah, so the other part that they have is the monitoring part, which I'm going to talk about briefly. So you can hook that monitoring into as trigger point triggers for your auto scaling group to either increase the capacity or decrease the capacity. Well, this is Amazon service. We're not currently using this feature. I think it's like part 2 of your moving to the cloud effort. It's kind of advanced. You got to make sure that you set up all the trigger points properly. You really have to understand your application well in order to use this correctly. So we're not using this yet. Yeah. Yeah, CPU, memory, anything that can be exposed, that can be monitored by their CloudWatch infrastructure service. So most of the typical stuff that you can imagine on a Linux box, CPU, memory, disk, swap space, and all that good stuff. I'm going to skip this. This is configuration. So CloudWatch is their monitoring solution. So you can monitor all your EC2 instances and all the major or critical pieces, right? The CPU network, the I/O, and all that good stuff. And then any of those things can be used as a trigger point for the load balancer. And it's pretty nice. You can access through the management console, see the graph and stuff like that. EBS, remember that I said an EC2 instance had some storage, but it's non-persistent. So one way to save something on is EBS, which is a persistent storage. So you can just mount that to your EC2 instance, save whatever you want there, and you can just remount it the next time that your EC2 instance comes up. And that way, whatever you want to store are persistent. You can also take backup and store in S3 as well from the EBS. So S3 is a slightly different storage. It's meant to store objects rather than files. And they have a concept of buckets. These are the buckets. And within each bucket, you can store objects. Object can be anything you want, a file, an image, a video, audio, whatever. They consider unlimited storage, so it's very nice. You can store up to 5 gigs per object. And the cool thing is, I think some startup leveraging this technology for providing service like image and stuff like that, because the object can be made publicly available. through some kind of access control rules. Okay? And you get charged by how much being used and how much. There's API that you can get to it, you get a list of objects and stuff like that. SimpleDB is not really a database. It's for structured non-relational text data. So the keywords there is text, right? Only store text. It does not understand any other data types. The key things are it is highly available because it's a shared data system, and it's zero administrative overhead because we don't have to worry about it as developers. They manage that for us. Unlike Oracle that somebody has to manage for you, right? The other interesting feature is good and bad is the auto-indexing. Everything that you store on there is auto-indexed. So even though you don't ever query by certain attribute, it's still indexed. So there's an overhead. There's the concept of domain. Domain has items. Item basically a role. Each role has a primary key. They call it an item ID. And you can store multiple attributes within, multiple values within the attribute, if you will. Schemaless, so developers can just go. They don't have to wait for DBA to approve the change in adding columns or removing columns and stuff like that. So it's a very nice feature. Certainly, there's limits in terms of how much you can store per domain. It's 10 gig per domain. So if you have a lot of data, then you need to consider sharding, which I'll talk about that briefly. There's limited on how many attributes per item you can store, as well as how big each value can be. It's 1K basically. So it depends on the data that you store. You might have to do some clever tricks. There's a SQLite SQL query. By default, it returns you only 100 items, so you need to be aware of that. The maximum is 25 items. Right? They can't just return you 100 items, 100,000, because there's a shared data system that's serving all kinds of customers. So it's eventual consistent system, meaning if you do a put on that attribute, and that while that item is being replicated to other replicas, when someone else trying to do a read, they might get a stale value. So it's eventual consistent model. So as a developer, you need to be concerned about this model in terms of how that affects your application. And when you talk about eventual consistency, you always mention CAP theorem. I'm sure many of you are familiar with this, so we're just going to quickly go through that. Consistency means all nodes see the same data, which is what we all know about database, right? Availability tolerant of node failures. And partition means tolerant of message loss. And SimpleDB is the AP system. The trade-off is the eventual consistency for being highly available and tolerant of network partitions. Right? If there was a network partition, you still have access to the system, but the data might be stale. That's the design decision that they pick. So they provide two different consistent model. The eventual one, which we just talked about. They also provide this consistent read. So if you really want consistent data, right, to get the most up-to-date value that someone just did a put, then you can use this at a price, right, which is higher latency and low throughput. So there's a trade-off in your application you need to think about which model you want to use. There's some optimistic concurrency control mechanism that you can use. They have something called conditional put or delete, meaning when you do a put, that certain value have to match, just like what you do in a database with a version column, for example. It's the same strategy. SQS messaging is pretty simple, but the nice thing is we don't have to worry about managing message bus or RabbitMQ, whatever that people use. It's being managed by Amazon. It's being available for across the internet. Certain constraint you got to be aware about: the size, how long the message can be retained over there. Yeah. I'm sorry? On the SimpleDB? No. So the key thing is it's guaranteed to deliver at least once, but could be multiple times. And order is not guaranteed, so you got to design your system to deal with that. So this is the pull model, and this is the push model, the SNS. It's a topic somebody publish or send a message, it's going to be pushed out to the listeners or the subscribers. That can be either an email box or another SQS or another application. So this is typically used for workflow kind of system. You want to trigger a process, send a notification that triggers the process. All right, so the last part is security. So how do you access these EC2 instances? So when you sign up for an account, they give you basically an access key and a secret key, right? Secret key is something that you want to keep to yourself. But at the time of making a request using HTTPS to these services, then the secret key is used to sign the request, creating each MAC out of it with expiration built into that. And that way, they can't replay the message, if you will. So that's one way of securing access to your EC2 instance or the data in SimpleDB and such. All right, so now we're going to talk more about Netflix-specific stuff. All right, some more questions. What are the device types that you can watch movie instantly from Netflix? You gotta name all of them. All right, okay. All right, how about this one? This one's good because so Netflix has to certify all these DVD players and TVs, right, for streaming. How many of these devices that Netflix has been certified so far? How many of models of DVDs, players, and TVs that has been certified by Netflix? It's a number. Well, I'm going to go with the 300 one. It's 370 type of devices been certified. That including the DVD players and also TVs. Okay. So before a movie is made available for streaming to the subscribers, movies have to go through something called encoding process, right? So they have to take the movie in whatever format that the studio provides to Netflix. They encode that into a format that can be streamed down to all the device types. And also they encode it in for several different bit rates, because it depends how good your DSL provider or your internet provider is. The player will switch to the correct bit rate to provide a good service to the scan film? Oh, no. We get it in the form of DVDs and stuff like that. No, we don't get it in film. No, we don't. So this is it's a huge process. It's a huge, complex, time-consuming process, because we get like a batch of movie, right? Because they just made a deal with ABC, for example. We're going to get a batch of movie, and they're going to have to encode that within 10, 15 days So those movies can be made available to subscribers and in different device types and bit rates and stuff like that. Take a guess how many EC2 instances are being used for that encoding process. 10,000. Close. Keep going. Keep going. 50,000. 4,000. Who said 4,000? So about 4,000 EC2 instances are launched for the encoding process. And when they're done, they shut that down, right? Now you can realize the elasticity property of the cloud, right? Otherwise, you're going to have that 4,000 machines sitting in your data center humming, consuming electricity while they're not being used. Okay, yeah.
Certainly, the argument with Amazon is a product value elasticity. You just spoke about having 4,000 instances. So I'm trying to square this with the conversation that I had with a friend 3 weeks ago. Who was wanting to use Amazon Web Services for doing some heavy-duty load testing, and he needed a large number of instances, and Amazon negotiated him down to 700.
Yes.
Okay, suggests to me that you got some special,
Yes.
had a very special SLA with Amazon.
Yes, that's a good point. I kind of lie about the elasticity. You can't just go and ask Amazon, hey, I want 10,000 machines. That's not going to happen. They have a limit. Huh? Yes. So you're right. So I kind of exaggerate, if you will. But yes, Netflix has a special deal with Amazon to allow us to get access to that large number of machines, as well as they have different tiers, if you will, right? For you and me as a developer, we can take out a credit card and get onto an EC2 instance. But to get to hundreds of machines, they have a model called reserve instances. So you pay upfront a certain amount of money to reserve 1,000 EC2 instances, right? And then you pay when you use them. So that's the model that we use as well. But we do have a contract with them in terms of making sure that they have enough machine for us to use. Yeah, because we know we're going to use the EC2. We know we're going to need those machines anyway, so we're just going to go ahead and pay it up front.
Can you give us some sense as to the total number of instances you use, what the range is?
Well, for encoding, it's definitely about 4,000, right? For just the day-to-day applications that power some application is roughly about 1,000. That's to handle the peak load. EC2 instances. Oh, that's for encoding. I'm talking about 1,000 just for serving. Oh, if you add them up, it's about 5,000 then, yeah. The range. Well, when we do encoding, we actually spawn up that many. When we're done, we shut it down. The 1,000 is continuous running to serving live traffic. Yeah, 1,000, yeah. No, that's for, yeah, people watch a lot of movies. I think we are, but I don't know that for sure.
I think WikiLeaks is right now.
WikiLeaks.
Yeah, don't you use a lot of CDNs like level 3s, etc.?
Right. I mean, the other part is streaming does not involve EC2 instances, okay? Because streaming, I mean, the flow of watching a movie is you pick a movie and then the movie starts, right? When the movie starts, when the streaming starts, right, EC2 is out of the picture. It's now the CDN is in the picture, or that's delivering the bits down to your DVD player or iPhone, whatever.
So do all of the movies I watch through the S3?
No, they live on CDN.
I noticed you're using, do you use CloudFront or are you using a different CDN?
We're not using CloudFront.
What are you using for your content distribution?
Akamai and another one more I forgot. I can't remember one of those. They consistently renegotiate the rate because of the growth that we're doing. Oh, to S3? Well, they have the API, right? You can upload just like any, they have the S3 API. Huh? Yeah. So we split them up. We upload them up there. You probably can tell from the slide that S3 has a 5 gig limit, right? So we have to chop them up and then ship them up there, run encoding. Yeah. That's their problem to worry about. That's the beauty thing about being in the cloud. But yeah, they did run into some of those issues. Oh, the encoding process? It also depends on how many movies that they need to encode, but it does take a while. No. It's a workflow. It's a workflow process, right? You go to step 1, step 2, steps 3, and some machines are dedicated for certain steps and stuff like that. No, I don't know that. Yeah. But the encoding process is running totally inside Amazon data center, right? Not in our data center. Oh yeah, at the uploading time, yes. So that is, yeah, there's only as big of a pipe that we can use. That's it. So but remember, right? S3 is available. It's shared. Well, we let them worry about how to distribute the data on S3 because they handle that on their end. But when we upload, you're right. It's a single pipe that we go through. So there is only up to a certain amount of speed or amount of data that we can ship at any point in time. Yes. Oh, moving the file into CDN? So once the encoding is done, everything has to be merged into it's multiple files, not a single file. And then those files are uploaded. I don't have the specific how that is done. But I mentioned it's not that difficult because the movie's been encoded and split into maybe 10 files. All right, so apart from the encoding part, for day-to-day kind of functionality that for supporting, watching, browsing movies, searching, viewing your history, looking at your queue and stuff like that, are supported by a bunch of services like these, right? So the entry point is through the API load balancer, and this is publicly accessible, so that the incoming request could come from your Xbox, your PS3, your Mac, your PC, and such. And then it hits the API. The API will talk to a lot of internal services to get to the data that it needs to serve that request. Okay. And a lot of our stuff is backed by SimpleDB, S3, SQS for all the messaging that goes back to the data center. Notice I have Memcached up here. The latency on SimpleDB is pretty bad compared to Oracle. Right? It's in the range of 200, 300, 500 milliseconds. So it's pretty bad. But what you get is the high availability for it. So we front a lot of data that exists in S3 and SimpleDB with Memcached. Okay. So we have a pretty decent cluster of Memcached for each of the services. Depends on the amount of data. And this is one of the missing infrastructure pieces that Amazon doesn't have. I'll talk about that in seconds. Any questions on this slide? So this takes about 1,000 EC2 instances just for that picture. Yeah.
So every time I go to am I talking to AWS? Every time.
Yeah.
If this is down, Netflix is off the air.
Not totally. If you're using PS3, not iPhone, we can fall that back to the data center because that's been working before, right? So we have a fallback strategy if the cloud goes down for that. But if you go to iPhone, that's a different story.
In general, it sounds like Netflix is pretty much dead its business on Amazon.
Yeah. Yep. Oh yeah, I mean we depend on a lot of other people, right? The CDN, of course. That's why we got to have redundancies by working with multiple CDNs. When one fails, we switch over to the other one. When there's glitches, network glitches, we switch to the other CDN. So we got to make you guys happy. Yeah.
So you said I thought you said Memcached is also running on EC2.
Yeah, yeah.
But there is a latency, right, to reach from your Xbox to that Memcached. There is you're going over the internet, right? You're saying that latency is few milliseconds only. I mean, when you say you're running Memcached, Amazon giving you infrastructure for Memcached also?
So what I'm trying to describe here is if a service talks to SimpleDB to get certain data out, it takes about 300 milliseconds, right? So we take that data and we shove it in Memcached. So the next time we go to Memcached and get it, that takes like 5 milliseconds.
And Memcached is supported on EC2 instances again.
What do you mean by support? We treat it as one of our applications.
Do you need like a larger memory, right?
Oh yeah, yeah. So for those EC2 instance table that I described earlier, we pick one with the high memory for the Memcached. Yeah.
Memcached, though, if you update anything in it, it's not pushed out to SimpleDB, or you could end up, if your Memcached fell down, you could lose
Yeah.
data.
When we do update, we update 2 places.
So you're handling replication within the EC2 cluster yourself.
Right.
So it should be pushed out.
That's correct. Yep. With what? No, that's one of the missing pieces. Yeah. Memcached, caching service. So this kind of I showed earlier, we for each services that we have, right, we basically put it in its own security group. We wrap that around with an auto-scaling group, right? So if one of those instances goes down, we don't have to be waking up in the middle of the night. The auto-scaler will basically launch more instances for us. So it's very, very nice. Okay, so another question. For SimpleDB, right, we store a lot of data, the random history in the queue. guess how many items that we have in SimpleDB? It's basically a row in a database. I'm sorry? Keep going up. 10 billion? It's too high. 2 billion. All right, each one of you get one. So it's about 2 billion items. So SimpleDB is charged by how much data we store up there, as well as how much data flying out of there as well as how long does it take to execute a query. So that's their charge. So for S3, we store the compressed rental history and some streaming activity logs. So the cool thing with SimpleDB is in S3 is we don't have to be concerning about running out of storage. Unlike we do that in our data center, we constantly will have to go out and buy more disks, right? So this is kind of one of those things that you just do it and you don't have to worry about it too much and let Amazon worry about it. No, currently no. Well, when we started out, only East Coast is available. But we are looking into providing both West and East Coast. I'm sorry? For the streaming, yeah. So at the end, we kind of put down a list of what are the missing infrastructure services that we wish Amazon would provide. And because they don't exist, we kind of have to build it ourselves. One of them is discovery service, right? If you have a lot of services running and these guys talk to each other, how do they find each other? Right? There's no existing solution for that. So I mean, it's not a really complicated service, but it's a needed service. So we built one of those. We also built middle tier load balancer. They have a load balancer for external facing, right? There's no middle tier, right? So one is to discover what are the instances for that service. The second one is how do you do load balancing among those. So we have to build those. The other thing that is this is the one I built, the encryption service. There's no service to do encryption of some data. The big headache there is doing key management. There's no good solution out there right now for key management. We have a decent one. Caching, like we talked about, they don't have a caching service, so we kind of use the Memcached, and then wrap that with the code so it's discoverable, and that would fit into our model of discovery. And we add more code so we can instrument that. Okay. So middle tier load balancer and discovery kind of work hand in hand. It goes here and discover all the services, right? And then it figures out which one should it talk to by some kind of round robin load balancing strategy, whatever. And each service periodically sends a heartbeat to the discovery service, right? So if it's down, this guy will flag it. If it doesn't get two heartbeats from a service, it's going to mark that as down internally. And when this guy is going to ask for that, it will notice that, hey, that one service is down and such. All right, so initially, we were moving small pieces from the data center to the cloud. And with that, we always have a fallback strategy, right? If things doesn't work in the cloud, we fall back to the data center. So it's a pretty safe approach. No. Well, you can ask, but I don't think they're going to do it. Yeah.
Why would a service go down if
Maybe it's a bug. Maybe it's a bug. It's hardware breaks, network glitch, router goes down, bad configured routers.
Hardware glitch and all that should be handled by the EC2, right? Like, they don't. It will move. The VM will
Yeah, but within that 15 minutes, what are you gonna do,
it
right?
takes 50 minutes to move the VM.
No. What I mean is the network glitch that have a network partition to your service, right? Let's say they misconfigure a router that route traffic to your service because your service is in that area of a data center. Somebody has raised a hand. So I was saying that initially we just moving small pieces, and then we have a way to fall back. Also, the other strategy that we use is shadow technique. So whenever a request comes in for a service, we'll basically do an asynchronous kind of forward that request to the equivalent of that service in the cloud, just to kind of testing it behind the scene. But for the iPhone launch, I'm not sure how many people are aware of this iPhone launch in June-ish, right? It's a much different kind of experience, as you will, because there's no fallback strategy. Everything has to be working in the cloud. All the infrastructure pieces all of them are running in the cloud. In addition, when Apple opens that gate, right, of letting users download the app, we don't have control of that. So these are kind of issues that we have to worry about. And it has to scale on day one. We can't, throttle our users, right? So it was a really interesting experience to go through the iPhone launch because of that. No fallback, no ability to limit the access to that. So we did a lot of testing. We leveraged this service for doing cloud-based load generations, and we leveraged this almost to the extreme. If we think something is really slow, just add 10 more instances, right? So, so this is where this comes in really handy for this kind of stuff. Yeah, we do have a model. We do have a model in terms of we figure, here is the iPhone launch. What can you do in an iPhone launch, right? What are the requests that's coming out of iPhone into our API layer? How many people is going to download that app? What are they going to do in the first 5 minutes, and such? It went pretty smoothly. There was no major glitches. There was some minor glitch a couple days in, have to do with network issues. Huh? No, I mean network issues inside Amazon data center.
How are you able to predict usage patterns of when people will be watching, not only like where the peaks and when people will be watching, because up to this point you're not mobile, you're accessing
Right.
more like PCs.
Yeah, I mean it's a rough model, right? So we figure out how many iPhones are out there, how many of that are actually Netflix subscribers, right? What are the things they can do in the app? You can search, you can browse, you can watch a movie, and there's kind of almost like background napkin kind of calculations and go from there, and then multiply that by 5 or 10, right? So. Yeah. Well, as far as I know, this is the only kind of initiative that falls into this bucket. To move the rest of Netflix, it's not going to be like this because we have existing functionality already. So it won't be like this. I mean, if Android comes around, it's the same back-end infrastructure that will serve that kind of traffic. Yeah. No, I mean, we have to ride the wave, right, of the iPhone wave, the iPad as well. So it was a big, major initiative, a big, big win for the company. That's why the stock went up. No. All right, so this I stole from Adrian's slide deck as kind of comparison with what's in the data center, used to be in the data center, and what's in the cloud. The database, right? This is key value, eventual consistency model. We don't use session. Obviously, you know session is bad, so we use share memory, memcached session, right? We have to deal with latency protocol. We layer our services, and we instrument the heck out of these services. We have to know where the bottleneck is, right? Because service can call another can call another service. We have to instrument along that path. Who is the slowest guy in that chain? So we have to instrument that. That's very key to understand what's going on when a problem happens.
Your instrumentation running all the time, or do you turn it on when there's a problem?
Good question. So we have a way of doing 10%, 20%, 30%, right? All right, some of the things that kind of good to know. So how do we deploy application to hundreds of instances in the cloud? So you definitely need some automated way of doing this. You want to be able to click a button and let it go, right?
You have the ability to create your disk image, whatever, on these local itself.
Right.
And then can't you just copy it and make up instances?
That's kind of a nutshell of what has to happen, but trying to deploy to 20, 50, 100 instances and making sure they all work, you want that to be automatic, right? You don't want to be somebody sitting there typing a script. So that's very key there. Yes, you have a process for building the AMI, right? From take an existing working AMI, build it, upload to EBS or S3, click a button, deploy that to 50 EC2 instances, and kill the other old 50 EC2 instances. Make that seamless. That's the challenge.
You have ETL experts that help you do this.
ETL?
Extract transfer flow, your install data migration.
Well, that's for data. This I think is a different topic. Yeah. So in the cloud, because it's not in our data center anymore, things going to happen, and you have to have that mindset with dealing with failure day one, right? If a service that you call goes down, what is your fallback strategy, if there is any? That's kind of the first question you want to ask when designing these guys. You're going to get a lot of 503s or 408s from Amazon services because there is a share system. They can't go down. They can throttle you, but they can't go down. Your application depends on their services. You have to be able to deal with this. Okay. Figures out what is the read and connect timeout for all these layers in your infrastructure. And as far as the persistent strategy, sharding, it's a must because of the limit that we just talked about, 10 gigs per domain, right? 1K per value. As well as when we move data up to the cloud, writing to a single domain, I mean, you don't get that much of a higher throughput. But if you have 100 domains, you can write all that in parallels to achieve a much higher throughput. So sharding is definitely a must. This is back to the point that I pointed out earlier, instrument the heck out of the services. Every request comes in, we instrument not only the time that it comes in, the time it takes to deserialize the payload, the times it makes to serialize the payload, the times that it passes that request down to the next guy, and so forth. And have the ability to correlate that single request along the chain. Right? So that will give you that view into your whole system. Yeah. It's not that difficult, actually. It's something that is an architecture that you build into all the services. There's some small piece of infrastructure that you built, and then everybody have to use that. So essentially, request comes in, create some unique ID for that request, pass that down. When you make an HTTP request to the next guy, pass that down as a header. Right? That guy will pick it up and pass that down to the next guy. So everybody's following that rule, if you will. And when we build libraries to serialize the payload or deserialize the payload, it's going to pick that up as well and instrument that and put that timing in maybe thread local or someplace that can publish that time at the end of the request to some central repository. And we do that by do logging and put that log into Hive that will allow us to do all that kinds of crunching and querying and stuff like that. This is just about SimpleDB. As I mentioned before, it's only text, and it's sorting by lexicographical, I guess. So when you're storing numbers, you want to pad it. That way the sorting will happen correctly as you expected, as well as date, using a consistent date format. Dealing with null is kind of interesting. You might have to use kind of a null value to signify it's a null. Because without null, it's going to take Amazon a long time to do a query for you. And eventual consistency, we talked about that for the get input. Sharding, I already talked about that to get around the limit. And if you have a batch job to delete a lot of items, because we have things to delete, so delete those in batch. Not only is faster, it saves money and time. S3, if you work with that, you kind of know a little trick to achieve the high throughput, making sure the keys that you're going to upload is in sorted order. And also, they use kind of a try to figure out the path of where you store the object. So you prepend it with an object key. With increasing 4 to 6 digits, that will help the right throughput as well. SQS is pretty trivial. It's basically used to decouple the system, asynchronous processing, and stuff like that. So that's kind of what I have.